My name is Mario Macías, and I'm from Grafana Labs. I don't really know the background of all of you. I don't know how familiarized are you with observability, telemetry, and so on. So I will do a first introduction of what we do. Then we will show you, or we will talk to you more about Grafana Vela, which is a new project that is going to be released pretty soon. And then let's talk about its performance. So Grafana, for the ones you don't know it, is a company that has a product for doing dashboards. You can visualize your data, create your own dashboards, but also provides open source products for the data ingestion, the data storage, the data query. And we are soon releasing an application observability product that lets you see at a glance how your services are working. You can get a view of your service, how are they performing, and some metrics about them. The application observability product is able to show metrics about your services. A metric is, for example, how many requests per second it is receiving, or a given percentile of the response time. Also, the application observability lets you show traces about your application. For the ones not familiarized with the term, a trace tells you for a given invocation of a service, when it starts, when it ends, some information about it, like some parameters or return codes, and even allows you to show context about who invoked this function, this service, or which other services it's invoking. To get this information from your application, you need to instrument your application. Instrumenting your application means to add a layer for telemetry. This telemetry layer will inspect some points of your application, like, for example, the web services, and will aggregate some information from them and will report it to a collector. It can be a local collector, or it can be a remote collector, like the Grafana cloud service. So Grafana is highly involved in OpenTelemetry. OpenTelemetry is a collection of APIs, software development kits, and tools, and provides a data format for metrics and traces, and a set of libraries to create and report them. OpenTelemetry is open, is vendor neutral, so you can use them with Grafana, but if you don't like Grafana, you can move to another provider, or even you can build your own local metrics collector. As Grafana is open source itself, you can install it locally. With Python, you have two ways of instrument your application. One is automatically. So you install this OpenTelemetry Bootstrap program. You provide some information about your instrumentation, like the service name, how do you want to export the data, and an endpoint for for example, for the traces or for the metrics. Then you can run your application, your Python application, with this OpenTelemetry instrument, and this will automatically hook into different points of your program and start instrumenting it for free. If you need more granularity, or you want a less general solution, you can manually instrument your application with inserting the probes and the trace points into your code. For example, you can instantiate a trace provider, a span processor, and then in some points of in the points you want to instrument, you can start a span do your work, and when this width block goes out of the scope, the span is closed, and everything else is automatically aggregated and submitted. You only have to worry about instantiating the providers, the processors, and at some points. Let's talk about eBPF. It's a hot topic. Many people talk about it. So eBPF is a just-in-time virtual machine that runs in the Linux kernel. That means that the Linux kernel is now programmable. You can insert programs inside the Linux kernel and inspect what's going on there, or even override its behavior. It also allows you to inspect user space programs, not only the Linux kernel, but you can tell the Linux kernel to instrument or to hook those, to launch those small programs you load there into when a given user space event happened. This is something that already existed, like named K-probes and U-probes, but before eBPF, this was a pretty unsafe or unstable way to do things, because an error in your code could mean hanging the Linux kernel. So with eBPF, everything is more stable and safer as the programs are pre-verified. So, for example, imagine we have a program that wants to trace each new HTTP connection. You have a process in the user space that will invoke a function via libraries in the kernel that is the TCP connect. And you have this Grafana Villa or another program that wants to instrument this function. So the first thing it needs to do is to know that this function exists, how it is structured, and then load a BPF probe. This BPF probe is a piece of software that is pre-compiled in this binary format accepted by the eBPF specification. So it is loaded there. When you load it, say, okay, attach this to this given function call. So when the process connects a part of the TCP connect function, this BPF probe will be triggered, and you can collect some information there, for example, just the start time, and you need to communicate it back to the in that case, the Grafana Villa process. So eBPF provides maps, which are different data structures, like dictionaries, but also some kind of queues, ring buffers, and so on. That way, the instrumenter process can get back this information and then can build and aggregate the metrics and do whatever they need. So what are the advantages of eBPF? First is fast. It's a pre-compiled binary with a just-in-time compilation. So you will get near native performance. It is also stable. Programs are pre-verified before being loaded. So eBPF will prevent some unallowed memory accesses. It will even prevent memory loops. Even if it's clear to you, sometimes it will complain even if there is no infinite loops. If it cannot really verify there's not an infinite loop in a given loop, then it will complain and won't let you run the program. And it is also clean. If the monitor program crashes, all the loaded resources are freed. So you can do it without being afraid or polluting your kernel runtime. But it also has many disadvantages. Like on one side, it's very hard to debug. A part of K-printfs, there's no other way to debug. The probes you run are often dependent on the implementation details of the software. That means that you need to know how the data is structured by the compiler, or how if you are instrumenting processes that are not for C, maybe Go, you need to know how the arguments are passed. You need to follow the architecture, language, or compiler conventions, like big endian, little endian, and so on. So changes even in the underlying system, in the kernel, can break your code. And another disadvantage that many SREs will prevent you to run eBPF programs is that you require privileges to load this into the kernel. What is Grafana Bela? I don't really know how to pronounce it. Grafana Bela allows you to instrument your application like this telemetry, automatic telemetry layer we saw previously to instrument Python, allows you instrument your application directly using eBPF. So when you run Grafana Bela as a process into your host, it can inspect the runtime and libraries of your application, and also some events in the Linux operating system. So it will be able to know the start time and end time of many different functions, some attributes like some arguments, the return code. So it will be, from this information, it will then aggregate it and create metrics and traces for your web applications. And then it will expose those metrics and spans as OpenTelemetry. You can send it to any OpenTelemetry collector. It can expose the metrics as Prometheus format, which is another open format to show metrics, or can send it directly to Grafana Cloud. To run Bela, you only need two arguments. First is tell Bela what to instrument. You can provide Bela an executable name, an executable regular expression. So if you just put a dot, it will try to instrument all the processes in your host. And you need also to provide an exporter, a way to export the data. If you are using, for example, a local OpenTelemetry collector, you just set the address for it and run Bela, as we said before, as an administrator, so with sudo. Then Bela will do the rest for you. One of the advantages of Bela is the performance. Being compiled and being in native language brings some performance improvements over instrumenting your applications with other languages. This talk, the research, the measurements behind this talk started after Grafana is involved in OpenTelemetry, and we got some complaints about OpenTelemetry that got some notoriety in places like Hacker News. So we started to think, are the Python OpenTelemetry libraries slow? We got this complaint, this issue we saw that into a repository in GitHub telling that someone complaining, all the Python services were very slow. They have very slow HTTP requests. But that was probably a mistake on their side. Because they weren't using the batch processor of metrics. They used a simple spam processor. That means that for every trace you create or you inspected, you create an export process, and for every service you received, you created another invocation to another remote service, and that's why everything was almost doubled. If you use a batch processor, you will aggregate multiple invocations and will submit them periodically and not in real time. Other person in the OpenTelemetry Python repository, they also complain about the trace overhead in its example, but the problem was also, again, on their side. They had some errors in the creation of the benchmark. But at that point, we saw some visible overhead running OpenTelemetry in Python. So one advice they gave him is to add sampling. So when you collect metrics, you get aggregated information. But if you are collecting traces, probably it's not a good idea to collect one trace for each invocation to your service. So you need to sample and say, I want to trace maybe 1 out of 10 invocations, because of the performance impact, but also because you will generate so much data that you will get a very expensive bill if you are using a cloud observability solution. Trying to respond, the question is Python OpenTelemetry slow? No, it isn't. But maybe we can do it better. So we tested the OpenTelemetry libraries and compare it with Bila, which doesn't run in Python. The OpenTelemetry Python libraries are written in Python, and Bila is written 90% in Go language and 10% in C language. The part that runs in the kernel needs to be in C, because the eBPF programs are very small programs. So we instrumented a pretty simple HTTP server. We tried to eliminate as much as noise as possible. So we run in bare metal hardware. We avoided to avoid virtualization latencies. We try to ping the processes to separate cores to get fair estimations of the CPU utilization, and even we turn off CPU throttling, turbo boost, and some things that could distort a bit the information. So we compared 3 scenarios. One is running this HTTP service uninstrumented, then was running it instrumented with the Flask Autoinstrumenter for OpenTelemetry. So we just run we run our service with this OpenTelemetry instrument program, and everything was automatically instrumented. And the other was running the server with Bila running in the same host. And these are the comparisons in terms of request time. So for 250 requests per second, you can see the response time of the service. Those are the percentiles, from percentile 50 to percentile 99. So you can see a small overhead in Python to the response time. The Python service needs to process the information, the request, parse the headers, parse the response buffer, then create the traces. And with Bila, you can see also some overhead, but it's close to the uninstrumented scenario. You can also see that if we add more load, this differentiation grows. So the response time is getting big and big, especially in the higher percentiles, while Bila remains close to the uninstrumented. We reach one point. This is the limit we found in our testing environment. So after 1,000 requests per second, we couldn't test with more requests per second, because that was the limit. With the Python instrumenter, we never reach more than those requests per second. Then we tried, and here with 1,250 requests per second, we only show the Vila the Vila request, and you can see that at some point for the higher percentiles, then even with eBPF, the impact starts to be noticeable. Also, we measured the impact in terms of CPU consumption. Those are the three services, the uninstrumented service, the CPU consumption with the manually instrumented service with the OpenTelemetry SDK, and the application with Vela. You can say that the application with Vela, the CPU consumption is often close to the consumption of the uninstrumented application. But we need to add, of course, the CPU that is consumed by Vela. Vela is another process that is consuming some CPU. So this green, you should stack this green bar on top on the yellow bar to get a more accurate view of the resources, CPU resources you are putting into or you are investing on instrumenting your application. So let's talk about the conclusions. I don't think Vela, we got some clear metrics here, but I don't think Vela is a replacement for OpenTelemetry SDK. It's just an alternative for some cases. By default, if I had to instrument my Python application, by default, I'd go to OpenTelemetry SDKs because they provide you more fine-grained details about your traces. Even if you are, especially if you add manual instrumentation, you can specifically tell what points you want to instrument, and you want to add all the details you want to that point. Vela just provides some generic information common to HTTP or gRPC services, but Vela won't know what is important for you. So you manually know what is important for you, so manually can instrument it. And also if performance is not a blocker, then if you are getting issues with performance, maybe you can consider Vela. When is Vela useful? We said when you have performance concerns, but also we found some other use cases in which could be interesting for you. For example, you have a big legacy application and want to give a try to an observability solution, but you don't want to spend resources, start instrumenting your application. So, or you don't want to recompile it or redeploy it. So you can get a quick instrumentation solution without having to change anything into your application. Also, we found some users using a very old version, in that case not Python, but Ruby. They got a very old version of Ruby and libraries, and the Ruby OpenTelemetry libraries didn't support their version. So they, thanks to Vela, they could get at least basic metrics and traces about their application. That could happen maybe if you're using Python 2. I don't know if that is someone still uses it, but if you are using maybe not only an old version of Python, but maybe an old version of or an unsupported web framework, with Vela you can also instrument it. Also, from an operational model, having separate or decoupling the instrumentation from your workload may simplify some tasks or may have some advantages. Here, if you add the telemetry stack to your application, if this telemetry time is is taking too many resources. You will need to grow all the resources dedicated to your application, because the telemetry is part of the application. Using eBPF and Bela in that case, this goes aside of your application. So maybe the resources of your application remain the same, and if you are having problems or you are struggling to generate or to parse all the telemetry data, you can scale the resources for Bela. Bela can run as a process, but can run also as a container or as a pod in Kubernetes. So you can scale only the telemetry part of your application without having to scale all the instances of your application. So thank you for your attention. Just let me inform you that Bela 1.0 general availability is going to happen next week. Bela is open source, so feel free to download it, use it for free, either with Grafana, with Prometheus, or with any other OpenTelemetry. And if you find any issue, you have any suggestion, don't hesitate to contact us to open an issue in the GitHub repo, or just contact me, ping me later, later outside here. So if you have any questions, I'll be glad to respond.
Can we have a round of applause for?
Thank you.
Thank you so much for that amazing session. Does anyone have any questions? Okay.
Yeah. Hi, I'm Prakash. I had a question regarding the Kubernetes implementation. So when instrumenting, the Bela binary, I suppose, will ship with the application container. Like it need to be included on where your application binary runs, right? And probably the sidecar for Prometheus, say, or a federated Prometheus will collect the metrics from the application metrics endpoint. So what part of, say, in comparison to the traditional Prometheus deployment or the chain or the stack, what part we can replace to use to take advantage of Bela?
Okay. Bela can run as a sidecar or also can run as a daemon set. It depends on how do you prefer to deploy it. Bela, in that case, if your application is instrumented with Prometheus, I guess you must have integrated the Prometheus API into your application, right? So with Bela, you don't need to integrate the Prometheus SDK into your application, because Bela will automatically inspect and create the Prometheus metrics for you.
Okay, so the code written for Prometheus, instrumentation done using Prometheus SDK kind of become obsolete, and it can, not absolute, of course it will have less features as compared to Bela, but Bela can still do its work,
yes,
even if that code is not present.
Yes,
okay,
exactly.
awesome.
Imagine you have your application, someone, and it's not instrumented with Prometheus. So if you want to give a quick try, you can just run Bela, and you will get the Prometheus code for free.
Oh, awesome.
Okay.
Thank you so much.
Next question.
Yes, hi. Thank you very much for the talk. I really appreciate people talking about eBPF. I think it could be the next Kubernetes or whatever cool technology of the year. So you mentioned, you measured performance by assigning processes to core so that you wouldn't get cross-contamination by kernel reassigning CPU time for each of the processes. Have you actually tried not doing that and reaching the point where you will test and see resource contention when it comes to time scaling on the CPU? So without assigning and reaching the breaking point.
Yeah, good question. Yeah, we did it, but we got some weird scenarios in which, for example, using Bela caused to the service to be faster than not using Bela. Things like that. Because, for example, under some loads, you got maybe 2 CPUs allocated, and then using Bela, then you have 4 CPUs, and everything was faster. So we got some, I think, difficult to explain scenarios. Not difficult to explain, but maybe will distract you from other aspects. But yeah, we tried. And it will be actually more realistic at some point than this synthetic stuff. Yeah.
Yeah, perfect. Thank you.
Thank you for the session. During the performance comparison, which processor provider did you use to get those metrics? And how many times do you execute the tests?
Oh, to be honest, I didn't do the experiments, so I can consult the person that did them and come back to you with that information.
Oh, yeah, sure. Yeah, because normally we see different performance metrics based on the provider, like if it's Intel, AMD, or Graviton, etc. Yeah, it would be a good information to share.
Okay.
Thank you, Mario.
Thank you.
Just a general question. Because you were saying you run it as a daemon set on Kubernetes, but like if you want to inject into another container, say on Amazon EKS, is that difficult because you need root, or it's just normal?
You need to run Bela as a privileged container. It's the only hard part, not because it's hard technically to do it, privilege equals true, but maybe your system administrator won't let you do it.
And you don't need anything specific on the actual container itself then?
No.
Okay.
No. It also depends on how do you run it. If you run it as a sidecar, you don't need anything else specific. If you want to run it as a daemon set, so one instance of Bela in a host instrumenting multiple processes, you will need to share the host or the host PID. So that single instance is able to see all the processes in the host.
Thank you.
Just one more minute. Do we want to ask any question?
Hi, thanks for your talk. Just wondering about a small question here. You were always comparing OpenTelemetry versus the Bela one. Can we run both at the same time? Is there any benefits of running both except for the extra manual traces that you set?
Very good question. At the moment, we are not yet prepared for that, but I don't want to promise anything, but we are working in a scenario in which you can run both. So you get the fine granularity advantages of running the manual instrumentation, but also Bela being running or using eBPF is able to inspect some internal status of your runtime or your framework, so you could get extra information, like, for example, how much time a request has been in queue and since the connection is received until it is dispatched by the scheduler. So we get this information already for Go, not for other languages, but yeah, at some point it will be interesting being able to get those two approaches just to get more information about the internals.
We would have loved to take more questions, but we're right on time now. And definitely, Mario is so much available outside. So if you probably have more questions, please meet Mario outside. A round of applause for Mario. Thank you very much.
Thank you.